we are defining yet another service to create. This is to ensure adequate availability of Merkle proofs to SPV clients after transaction broadcast, and to ensure adequate double spend notification to all relevant transaction parties. So a Bitcoin transaction, noting we have one here, can have many inputs and outputs, and each one of these inputs or outputs could hypothetically, depending on the type of transaction, be associated with a different party. So a 3 input, 3 output transaction, for example, could be associated with 6 different transacting parties, or more if there's multi-signature inputs, or a specific output in which multiple parties have an interest in that output. So you can have a lot of parties associated with a transaction, right? And they all care about a couple of different things. They care about MAPI responses. So, right, they care that miners have significant portions of the hash rate, have attested that they intend to include the transaction once it's first broadcast. These transaction participants also care that they are going to care about the SPV proofs when they become available from the miners. So SPV proofs, and they're also, finally, if there's a double spend or an attempted double spend or any of the other shenanigans that people sometimes want to try, mining network's going to notify the we're going to want a service that is capable of notifying transaction participants about any of these 3 classes of events. So upon initial, the miner intends that the transaction is going to be included in the next block. And then here's the proof that the transaction was included in the next block. And then any shenanigans that happen, the miner would be able to hopefully notify all transaction parties with that. Now, that's going to be known as this CastCorder thing that I want to create. So that's kind of the problem statement. Currently, we have MAPI, Miner API or Merchant API, and just basically each miner runs this little server that accepts transactions and then sends responses to, in fact, all 3 of these types of requests, right? So MAPI is going to incorporate initial transaction broadcast, SPV proof, as well as shenanigans. Those are the 3 things that MAPI pretty much does right now. And there's a couple other things as well. However, the economics of this are not very well developed. And currently, as one weakness of MAPI, yes, I can subscribe as the initial broadcaster, and that's the key, the initial broadcaster of a transaction. I can go to MAPI and I can broadcast it out, and then the miner will notify me about all of these sorts of things. However, if Alice pays Bob and Bob broadcasts that transaction and then Alice has a change output, Alice has an interest in getting the SPV proof on that change output as well. And she doesn't necessarily want to stay connected to Bob, and Bob doesn't necessarily want to have to run the infrastructure associated with notifying Alice that, yeah, the transaction you sent me 10 minutes ago, here's your change output. Like, what happens if Bob is running a website and Alice is visiting that website and she can't, she closed the browser window or something. It doesn't work very well. So can't rely on Bob, can't rely on other parties for this. And so the solution that people have talked about, and maybe this is a valid solution. It's just that nobody's built it into Mappy yet. And so I'll consider building this into Mappy. That's kind of why I'm doing this, is to get people's feedback on it. One option is to build into Mappy a mechanism by which non-broadcasting parties, so after a transaction is broadcast, can go back in and subscribe so that they also get a notification about all these different events and everything like that. So right now, first person to broadcast, so if we look at Mappy, right, and we're just going to say like this is time, right? So time goes on. First person to broadcast, they're going to get the OK response, and they're going to get the signed thing, and they're going to get hooks, and they're going to get all these things that they get notified about. Anybody else, if I broadcast second or maybe the third party, so there's 3 different people in the transaction, they get nothing. They say you get error transaction is already known, return result false, and nothing. Sorry, you don't get anything. No callbacks, no double spend notifications. Only the initial broadcaster of a transaction currently in Mappy, as I understand it, please correct me if I'm wrong, is going to receive anything back. So if I'm a millisecond too late as the second one, but I can send to different nodes, so Alice sends to node A, and then, Bob sends to node B, and then Mappy from node A gets, notifies the one, and the other person gets notified from the other miner. But that's really, really non-ideal, and it's also very unreliable. And, eventually miners are going to have dark fiber links and whatever between them and propagate really, really, really fast. And so that's like not even a viable thing to just send it out to different nodes, the different people, and then do that. And also again, it's very, very non-ideal and hacky. So we can either refactor Mappy a little bit to enable this support, but there's the caveat, which is miners don't really have an economic incentive to support. I mean, like, what if 1 million people went to a transaction and said, let me know about this? Is the miner really going to service 1 million callbacks? I mean, they can probably service one because they're the broadcaster of the transaction, and because that transaction pays a fee, which that miner is liable to receive if it gets into one of their blocks. So kind of all miners have a bit of an incentive using the transaction fee to notify the initial broadcaster, but every subsequent one, what if there was, like I said, 1 million? Makes it a little bit, changes the economics there. So refactoring Mappy to support that might not be the most ideal case. So I propose to create the CastCorder, which broadcasts and records CastCorder. So what it will do is provide an economic, it will be a third-party service that does not specialize in mining blocks. So I'm not like a miner having to focus on any of this stuff. And so what happens is I take payment, basically. So one of the outputs of the transaction, like we could say this output here, goes and pays a little bit of money, like maybe 140 satoshis or whatever, small amount of money, to the CastCorder server, right? So CastCorder actually has like outputs, has an interest in this transaction. So as a payment for the service, right, of doing what CastCorder does, it takes money from the, it earns satoshis. It's a revenue earning type thing. So CastCorder servers, what do? They are the designated first one to send a transaction. They are set up to receive very reliably these callbacks, and they have connections with multiple different miners. They can provide the signed Mappy responses from different miners to anybody who is designated in that Mappy or in the CastCorder output. And they can also forward any notifications they receive about Merkle proofs or double spend to any other entities associated with the transaction that request it through the CastCorder instance. So basically, if I am we got like these 4 different parties to a transaction, right? And they all basically are agreeing that this is the one CastCorder instance that they're all going to use. So for the purposes of this transaction, all four of the different parties, they get their transaction and they send it to CastCorder, and then basically CastCorder broadcasts it up to the different miners. And so those are different miners up here over Mappy. And then any responses that come back from any of those miners will now be kind of sent back to CastCorder as the designated recipient of all Mappy related things for this transaction. And then the CastCorder instance can forward this to any number of designated clients. Now, how do the economics work here? So we have the transaction, right? And I'm actually just going to say, yeah, this is here a transaction, and here are some of its outputs that go to wherever. This is the CastCorder output here. And in this output, I guess we can say, what does it contain? And what we would say here is, first, it contains Satoshis. So the Satoshis pay the operator of the CastCorder server. Hey, that's me. And also contain op push, op drop type things. So we push all of the authorized public keys, right? So suppose there's key 1, key 2, and key 3, and they're all public keys. They are actually included in the script of the output that pays. So maybe this is normally P2 PKH, pay to public key hash, but in addition, there's like op push, 3 public keys, and then drop. And those contain who is authorized to be talking to CastCorder about this specific transaction. So for each of these public keys, maybe it's 150 Satoshis each key. So if there's 3 public keys, according to the policy of the CastCorder server, then you would have maybe 450 Satoshis as required output amount for that output to be valid and for the CastCorder to accept it as a payment. So 3 public keys, that means you're paying 150 Satoshis. And then you got 3 different parties or people or and then what CastCorder will do is it'll take each of these public keys and associate it with, okay, so the one callback servicing request allowed for public key A goes to this URL. The one for B goes to this URL. One for C goes to this URL. And the other advantage here is we can support multiple different methodologies for doing callbacks. You can do server-sent events, WebSockets, HTTP callbacks, notifications, mobile push notifications for iOS and Android, many other different methodologies for service of callback requests to multiple clients. And that way we can provide, an economic, basically I'm paying for on a per client basis, the service of getting it. And then, multiple miners are able to broadcast it. And this CastCorder thing is the designated one for Mappy. So we avoid all the problems and ambiguities with Alice tries to broadcast, but Bob already broadcasted, so now Alice doesn't get to have her proof on her change output. It's a way of solving the let's get these 3 type things that we need to each of the parties involved. So the initial signed response saying, yes, I am a miner and I hereby, will be putting this in my next block. Also, here's the SPV proof, and then any shenanigans that go on can automatically be serviced on an economically incentivized basis to the parties involved with the transaction. That's my proposal for chain sorry, I keep saying chain tracks. That's a completely different thing, and you should probably ignore it. That's my proposal. Sorry, there's a lot going on with this stuff that I'm working on, but I digress. For CastCorder, this is my proposal to create an economically incentivized transaction propagation, proof propagation, double spend notification propagation system for making SPV actually work, because I need to make SPV actually work. And so if you also need to make SPV actually work, then let me know what you think of this, because I'm about to spend a lot of time building it, probably another week. and hope that if someone has a better idea before then, I haven't already spent like a week building it. So anyways, if rambling, I guess, but let me know if you like the format of this very disorganized video, and I will see you guys in the next one.